first do a quick review with graphing. The first two classes I've been trying to focus on your ability to conceptualize position, velocity, acceleration, to think in terms of velocity and acceleration, to get rid of some misconceptions you might have about velocity and acceleration. A common misconception is that if my velocity is positive, my acceleration has to be positive, or vice versa. If my acceleration is positive, my velocity better be positive. That somehow those are connected. I'm hoping within the first two class periods we've gotten over that misconception, but more importantly, I want you to be able to think or picture velocity and acceleration directly. So we've been doing some graphing with that. Today's class is not going to be focused on graphing, so we focus primarily on working with equations. Now, the equations are telling us the same thing as the graphs, just in a different format. So today's class is focused on equations. But to start, I'd like to do a quick review involving graphing. So, Edgardo, can I get you to come on up to the front? Last class, this is an easier one. I just want you to come on up and do something. Okay? So Edgardo's going to walk around the front of the classroom a little bit.
Okay.
In fact, Edgardo's in good shape because he's the only one that doesn't have to make a graph.
Okay.
All right, so what I want you to do for Edgardo's motion,
And you're recording?
I don't have to.
No, it's all right. It's all right.
is graph his velocity as a function of time directly.
I have to do it like.
Okay, try to go only side to side, so we're not doing
Okay.
2D motion, so you can go across here.
Okay.
All right, so does everyone have it ready to go? All right, so give us a go, Edgardo, when you want to start.
Do whatever.
Yeah, do whatever you want to do.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay.
Stop.
Yep. So Edgardo, have a seat. Everyone, you should have your graph of velocity versus time. Put a 0 on your graph. Label your 0 so I can see what you meant by velocity of 0. Which way did Edgardo go first? This way or that way? To the left, right? I think he started here, right?
Yeah.
And he went that way initially. This is for all semester long, this will be our positive x direction. He started off by going in the negative direction. So his velocity initially would be negative. So I think if looking around the room, some of you just missed that. You had it backwards, so his velocity started off negative, and then he did a burst in the positive direction. This is his velocity as a function of time. I'd like next to graph his acceleration as a function of time. There's two ways we can get his acceleration, or at least two ways. One way is we can ignore this graph and try to think about it conceptually. What did Edgardo do? That should give us the correct graph for acceleration. Let's try to do it that way. And I'll start it off and maybe let you finish. Okay, Edgardo was initially not moving anywhere. I'll try to back up so the camera can get it. But Edgardo wasn't going anywhere. And then he started to head this way. So which way did he accelerate initially, positive or negative? Negative. So our graph is going to start off with a burst of acceleration in the negative direction. Did he keep accelerating in the negative direction? Like, did he go faster and faster and faster and faster? No. So he accelerated for a little burst that corresponds to that. But he did not continue to accelerate. He probably just coasted over here and then came to a stop. When he came to a stop, the act of slowing down, he was going this way but slowing down. When he was going this way but slowing down, which way was he accelerating? Okay, pause. positive. Now go ahead and try to finish the acceleration graph on your own. Not by looking at this graph, but by thinking about what he did. Try to finish up his acceleration. Okay. I've shown the answer up here, and most of you got it. Some of you, I think, were still a little unsure how to draw it. These acceleration points should be fairly thin on your graph, because he accelerated in bursts. He started, stopped, and then started, and then stopped. He didn't accelerate for long periods of time. So we get this graph conceptually. Now let's check it to see if it fits with the graph over here. Acceleration is the derivative of velocity with respect to time. So this graph should be the derivative of this one. At this point right here, what's the derivative of velocity with respect to time? How about right here?
0.
Right here. Here. 0, 0, 0. In fact, it's 0 almost everywhere. So the velocity, the slope of velocity versus time is almost always 0. So my graph of acceleration versus time should be almost always 0, which it is. The only spots where it's not 0 are right here. And there the slope is negative. Here, the slope is positive. Here, the slope is positive. There, the slope is negative. So from this graph, you can see negative slope, positive slope, negative slope. Which fits with what we thought conceptually might be the case. Negative, positive, negative. Okay? So we can get it by thinking about the situation. That's my first choice. You can start to picture Edgardo's acceleration. You see somebody moving around, you can picture the acceleration directly. But a good check on that is to make sure this is indeed the derivative of that. Okay, let me put that formula over here again, because I can never write it too many times. These are the two relationships that we're starting off with this semester. We're trying to learn how to work with position, velocity, and acceleration. In a moment, we'll be using F equals ma. When we identify the forces acting on an object like we did in statics, the sum of all those forces is going to equal the mass times the acceleration. So in dynamics class, often, but not always, we're going to be given the acceleration and trying to determine velocity and position as a function. So let's do an example where we're given the acceleration as a formula now, not as a movie, not as a graph, not as a description. So we're given the acceleration as a function of time as a formula. We're doing the same thing. This is just a different way of presenting it. And I'd like to figure out the velocity and position. And more specifically, I suppose I should write the velocity as a function of any time and the position as a function of any time. To do this correctly, I'm going to need to know some information beyond just the initial acceleration. I need to know what my initial velocity is. So let's say my initial velocity is equal to 3 meters per second, and my initial position is equal to 5 meters. If I'm not given that information, I'll end up with a plus c in my integral, and I won't be able to figure it out. Writing xi equals 5 is the same thing as writing x when t is equal to 0 equals 5 meters. What I mean by initial position is the position when time is equal to 0 seconds. That's what we mean by the initial. So the position when time is equal to 0 is the same as xi. Those are two ways of writing the same thing. So I'd like to find the velocity as a function of time and the position as a function of time. Okay.